Hello, everyone. Hope you all are doing well and staying healthy during these times. Once again, I am David Villafuerte, one of your project leads for BMES, and I'll be the one in charge of introducing you to the academic workshops we have for fall 2020. Now, for those of you who are engineering students in UC Riverside or somewhere else, you may or may not have heard about this application called COMSOL Multiphysics. If you have, that's great. You already have been introduced to one of the most crucial softwares you need in your engineering career. If not, this is your chance to gain a little bit more of an understanding on the features that COMSOL can provide to you. So what is COMSOL? COMSOL is a cross-platform finite element analysis solver and multiphysics software that allows conventional physics-based user interfaces. It is a very interactive application that would help model and simulate scientific and engineering problems that could be helpful to scientists and engineers in both academia and industry. So without further ado, let's get started. First, you have to download the COMSOL Multiphysics software online from UCR's BCOE list of softwares. I will put a link in the description box below so that you can download it. It is free for UCR undergraduate students. Once you get into the link, there will be further instructions regarding the download. If you are not affiliated with UCR, there will also be a link for the COMSOL Multiphysics software in COMSOL's official website, and you can get more information there. So now I have it downloaded. So right now, let's get started. Once it loads, there will be two options available on your screen. This will be the blank model and the model wizard. So the blank model is the button you want to click for starting a project simulation from scratch. This is recommended for beginners. It lets you be able to explore the different parts and features of COMSOL, which is always a good thing if you don't know how to make your very first model. The model wizard, on the other hand, is a more systematic approach to COMSOL, which can help you start in a more organized fashion, like setting up features for your model, such as the space dimensions, AC/DC circuits, chemical species, the mechanics, the math, and more on like sub features within those features. So for now, we're going to use the blank model for this tutorial. So let's click on blank model. So once you click on it, you can see right now there are different features within the blank model. By default, these are the features that you will see when opening a blank model. You have the quick access toolbar, which have buttons for access and functionality. You have the open button, the save button, undo and redo, copy, paste, and delete. So basically all the basic features for a common computer application. You also have the application builder, which is seen here under your home tab. It gives you an overview of the specifications of the model. This is also a toolbar summary for the modeling process, so you can control any of the menus. Inside the model builder tool, you have the model tree. The model tree basically gives an overview of the model and all the functionalities and operations needed for building and solving the problem. Next to the model builder toolbox, you have the settings window, where you can modify the associated settings of the parts of the model. So you can see when I select parameters, yeah, parameters have its own settings, materials also have its own settings, and more so if you add more parts of the model tree within the model builder, once you get more, but I will get more into that later. So next to the settings menu, you have the graphics, which is the area where the image of your simulation will take place, and it will be viewed according to the settings. This is where you can see the mesh geometry, result nodes, and also examine your model through rotating, spamming, zooming, and selecting different parts of your project. Below is the information window, which is vital to get the information during simulations, such as the progress and the log of the project. This is where you keep track of like major changes and help you see what is going right and what's going wrong with your simulation once you build it all together. So that's it for the black model in COMSOL. Now I'll show you the model wizard part of COMSOL. As I said a while ago, this will be a startup that has a more systematic approach. So first, click on the model wizard. First, it will ask you to select the space dimension. So typically students use two-dimensional models first and work up to 3D. Once you use two-dimensional models first, you get some practice and move on to three-dimensional models. Three-dimensional models will be expected for UCR students who are going something related or doing something related to senior design. So as a senior in undergrad, I suggest start practicing with your 3D models a year before your senior design class, so it'll be easier to master once you get the basic features. So in this example, we're going to use 2D first. So once you do select your space dimensions, the next thing you'll do is you'll have a list of physics-based concepts that will be part of your simulation model, and you're going to select which ones you'll need within your model. So features like AC/DC circuits, acoustics, chemical species, radio frequencies, mechanics, and the math and like other concepts that you need that are physical related that can be implemented into your model and simulated by COMSOL. So you have the AC/DC, which is basically about electrical engineering related stuff, such that'll compute the electric and magnetic fields in static and low frequency systems. You also have acoustics, which is used to compute the propagation of acoustic fields under various conditions in frequency domain and time domain. You have the chemical species transport, which is used to compute the concentration fields of chemical species in solutions and describe chemical reactions and transport through diffusion, convection, and migration in diluted and concentrated solutions. You also have the fluid flow, which is to simulate flow and pressure fields of liquids and gases. Heat transfer. Heat transfer is when you compute temperature and radiative intensity fields. You have radio frequency to compute the electric and magnetic fields in high frequency systems. You also have the structural mechanics, which contains interfaces for analyzing any deformation, stresses, and strains. And you also have math, which is solving partial differential equations or ordinary differential equations, moving meshes, sensitivity analysis, deformed geometries, and other mathematical concepts. Most of the time, if you are a UCR bioengineering major in 2020, you will surely use the chemical species transport and fluid flow. So most of the time during your 4 years of undergraduate. So let's use that as an example. So you go to chemical species transport and you select one of your sub features or like physics interface that you want to add. So you can click on, so for this one, I am gonna click on transport of diluted species. Click add. It'll take a few seconds and it'll be added to your study. Going down, we also commonly use a single phase flow, like a laminar flow. So a laminar flow is used in most fluid mechanics classes that you may have to take during your when you're taking your upper division courses. So let's add that. And once you get all of your interfaces added within this place, within this box, you'll click the study button. From there, you'll have to pick the kind of study that you want. So stationary is for when you used field variables that do not change over time. You also have time-dependent study when the variable change over time, and an empty study where you want to create a study node, but you don't want to have any study steps. So for right now, we usually choose stationary. And once you select that, it'll be under the added study. And after that, once you have that all set up, you can click done. So now this is similar to what we saw in the blank model for COMSOL, but as you can see here in the model tree, you already have a more organized fashion of what your study is going to be. So you have, as you can see, we have the transport of diluted species, the laminar flow, study, stationary. So everything's already here. You just have to make sure that you know which ones you actually need and which ones you don't, so that it doesn't get unorganized. This, in most cases, are used in the classes that I took in the recent years. So yeah, this is like an example on how to set up COMSOL and how to make sure that everything is set up before you can actually start making your model. So that is it for the introduction to the parts of COMSOL. In the next video, we'll be making an example of a transport diluted solution that will help you guys get a better understanding of the steps of the simulation. If you finished this video tutorial, please go like and comment and subscribe. Maybe even comment what would you like to see in the COMSOL Multiphysics tutorials. And yeah, with that being said, I'll see you guys next time. Peace.